ya.
Kuol, say hi.
Satu sih.
Kayak kedukuran deh. Mau ngomong?
Nih, wes rekam belum?
Udah.
Hai guys, jadi
Jujur gak kelihatan sih, agak gini.
short banget. Hai
Ya,
guys,
maaf.
jadi ini adalah orang di balik kamera. Tara, itu guys. Iya. Ini kita lagi di mana guys? Ketok. Tapi kayak agak deket aja nggak apa-apa, biar lebih jelas. Ini kita di mana? Kita nggak di Malang. Kita lagi di puncak. Ini kita mau glamping, terus ya tempatnya kayak industrial gitu. So this is the ambience. Ini ketinggian deh. Dan nggak usah terlalu jauh deh.
Today we are going to walk through the bubble sort algorithm using the sets of number 20, 35, 14, 7 and 67. Our goal is to arrange them from smallest to largest by repeatedly swiping adjacent elements if they are in the wrong order. Let's start our first step. First, we compare 20 and 35. Since 20 is already smaller than 35, we leave them as they are. And next, we look at 35 and 14. 35 is greater than 14, so we swap them immediately. And now, compare 35 and 7. Again, 35 is larger, so we swap them. And finally, we compare 35 and 67. They are in the correct order, so we move on to the next pass. Moving to the second pass, we do not need to check 67 again. So for the first, we start from the beginning again. We compare 20 and 14 because 20 is larger, so we swap them. Next, we compare 20 and 7. We swap them because 20 is larger than 7. And now compare 20 and 35, and they are already in order, so we stop here. And for the final pass, we compare 14 and 7. They are out of order, so we swap them to get 7, then 14. Then compare 14 and 20, since they are already in the correct sequence, so we can see the list is now sorted from 7, 14, 20, 35, and the last is 67. The bubbles have all settled and our data is perfectly arranged. And that is the bubble sort process. Simple, efficient for small datasets, and easy to visualize.
Okay, now we're going to move to selection sorting, where the number is 39, 14, 67, 29, 65. So we're going to check the 39 with the 14 first. If the 39 is higher than 14, then we will swap the 14 with the 39. And after that, the A++ will be moved to the 14, and the 14 will be checking with the 67, 29, and if there is a number that is higher than 39, or I mean lower than 39, will be put a I in the index of the number, and we will move the number into the exact number that we're going to change. And we're going to check it again. If there is a number that is lower than 67, if there is no, will be there is a 65 that is lower than 67, and we're going to move it, the index of the number, and we'll be checking again the 65. If there is a lower than a 65, we'll be moving the index with the exact index that is the number is lower. And we'll be rechecking it again, all of the index. If there is no miscalculate, then we're done.
Now, I'll be explaining how Bubble Sort handles duplicate data using this array: 22, 33, 45, 17, and another 33. In Bubble Sort, we compare adjacent elements one by one. If the element on the left is greater than the one on the right, we swap them. If not, they stay put. Now, look closely at our two 33s. When the algorithm compares the first 33 with 45, no swap happens because 33 is smaller. But what happens when we encounter the second 33? The rule is we only swap if the left element is strictly greater than the right. Since 33 is equal to 33, the condition left greater right is false. Therefore, no action is performed.
In this analysis, we will examine how the selection sorts algorithm handles duplicate data elements. We will use the following data as our primary example: 22, 33, 45, 17, and 33. The core action of selection sort is to scan the entire unsorted portion of the list to identify the absolute minimum value. In the first pass, the algorithm identifies 17 as the minimum and performs a long-range swap with the first element, which is 22. When the algorithm encounters duplicate values like 33A and 33B, it prioritizes the minimum value over the original index. Because these swaps can jump over multiple elements, the original relative order of the twin 33 is not guaranteed to be preserved.